Okay, today we're going to study sequences. Okay, this is a, you can say this is still part of the problems on numbers. That's true. But we have to study infinitely many numbers. Okay. That's called sequence of numbers. Okay. Well, if you take my basic math class, and we already studied a sequences of numbers. Okay. But most of the problems over there, we're just trying to figure out what is the next term. We already learned the two types of sequences. One is called the arithmetic sequence, other one is called geometric sequence. Okay, and we have to go over that first. Then we will study some more sophisticated problems. Okay. Arithmetic sequence are those the difference of two consecutive terms will be the constant. Okay, so you have a sequence, right? A1, A2, A3, A4, and then you label them, right? So the general term is AN. And the arithmetic sequence means the gap from here to here, you just add a constant. You add a constant, you get the next term. Add a constant, there are different many ways to describe it. Okay, so this is how you get the next term. And in other words, AN equals the previous term plus A. That's one way to describe it. Another way to describe this formula, this sequence is A2 minus A1 should be equal to A3 minus A2 should be equal to A4 minus A3 and keep it going. They are all equal to A. So that means the difference of two consecutive terms is going to be same number. Okay, so that's called the arithmetic sequence. For example, here's the example. Okay, now like we are given a sequence, right? And we're trying to find the general term. Okay, so formula for the nth term. Okay, so we only given first few terms, but we assume that there's a pattern here. Otherwise, only the few terms do not determine the rest of them. So we assume it's an arithmetic sequence. Then we see this is A1, this A2, this A3, this A4, right? And we find out the number is going to be, the A is going to be 3 every time we increase it by 3. Okay, right? So you can also add the 3 you can get next term, add the 3 you can get next term, add the 3 you can get next term. So the question is, how do you get a general formula? That's not easy to figure out. Okay. I know the next term would be 11 plus here plus 3, that'll be 14. Right. So let's see, how can I get a general term? Well, A2 minus A1 equals 3, right? A3 minus A2 equals 3 also. And A4 minus A3 equals 3. And so the nth term minus the term before that, an minus 1 equals 3. So you have this long list. But can I get the general as the nth term? So the trick is very simple. Just add all the terms together. All the terms on the left side, all the terms on the right hand side. How many of them here? You have n minus 1, many, right? N minus 1 rows here, right? Equations, right? So when you add them together, the left hand side, you realize that 2 cancel out, 3 A3 cancel out, A4 cancel out. So what is left is an minus A1. The right hand side is 3 times n minus 1, right? Because n minus 1 identity. So great. So then you get, because we know the first term, the first term is 2. So it's A1 plus 3 times n minus 1. A1 is 2. So this is a general formula. Okay, you can simplify. It's minus 3, so 2 minus 3 is negative 1. So 3 minus 1. Okay, so this is a general term. And double check that, okay? You can check A4. A4 is 3 times 4 minus 1. It's 11. Yeah, that matches what we get. Okay. Okay, so this is the general formula. Right. The next type of series called geometric sequence. Okay. Geometric sequence. Whoops. Okay. Yeah, sorry. The geometric sequence is going to be a geometric sequence. Geometric sequence are, labeled by like A1, A2, A3, A4, right? So here's the point. The point is that the next term divided the first term is the same as A3 divided by A2. It's the same as A4 divided by A3, and keep it going. So you are going to get the same number. We call it R. Right? You can also do like this: A1 to A2 to A3 to A4 is A1 is going to be A2 is going to be A times R. This will be A2 times R. This will be A3 times R. Okay? Just multiply the previous term by the same number, not add the number to add the same number to the previous term. We multiply the previous term by R, so you can get the next term. Okay. Now, can we get to the general formula? Right? We can do like this: A2 divided by A1, get R, right? Then A3 divided by A2 equals R, right? And keep it going. AN over AN minus 1 equals R. So how many terms here? N minus 1 equations, right? So this time we're not going to add them together. We're going to multiply them out. The term on the left-hand side okay, how many equations here? It is R to the N minus 1. So R times R times R, you have N minus 1 R there. But A2 cancel out, A3 cancel out. So all the terms in the middle cancel out, just only have AN, and A1 equals R to the N minus 1. Okay, so the general formula is going to be A1 times R to the minus 1. So the nth term of a geometric sequence is given by the first times R to the N minus 1. Okay, let's take a look at example. Okay, let's take an example. Yeah, given, look at the example. Given 3, 6, 12, 24, 48, and so on. Find the general formula AN, okay? As you see that the next term is the previous term multiplied by 2, right? In other words, the next term, this is A1, this is A2, this is A3, A4, right? A5. So A2 over A1 equals 2, right? Then A3 over A2 equals 2. Just keep it going. And AN over AN minus 1 equals 2. And you can repeat the same idea. You can use a formula already, but otherwise you multiply them out, right? And you have any n minus 1 equations. Okay. So all those canceled out. What is left is AN, and the first term is what? First term is going to be 3. We just care about the last minute, right? So the nth term is 3 times 2 to the n minus 1. Okay. Once you know the formula, then you can get, hey, the 100 terms is 3 times 2 to the 99. Okay. Okay. I wanted to find the general formula. Okay. Given 7, 10, 13, 16, find AN. Okay, please try and figure it out. Right? Anyone has a formula? So Andrew has answered. Great. Good job. Jaden, XU, Michael, can you figure it out? General formula? When you get a formula, double check, okay? Andrew, the first time when n equals 1, using your formula, you get 10. 10 is the second term. So how do you modify it? Yeah, you're right. So yeah, n minus 1. 3 times n minus 1. So when n equals 1, you get 0, right? Then you still get the first term. All right, let me finish this. Okay. All right. The increment is each time is 3, right? So 8, right? So you can do like this, but you have to figure out how many terms, right? So it's this is A1, this is A2, right? A3, right? So A2 minus A1 is going to be 3, right? A2 minus A1 is 3, and A3 minus A2 equals 3, right? Each time A4 minus A3 equals 3, and keep it going. And then AN minus A minus 1 is 3. So A1, 2, 3, 4, 5. So actually you still have N minus 1 terms. Then when added together, right, all the terms in the middle will be canceled out. So what is left is AN minus A1. Okay, minus A1. Okay, equals 3 to the 3 times N minus 1 because they have N minus 1 questions. Okay, so AN equals A1, A1 is 7. Okay, yeah. And if you multiply this out, it's going to be like a 4 plus 3N. Okay, you can simplify. Okay, so this is a general term. Now, sometimes we do not, the sequence is not arithmetic sequence, not a geometric sequence, but we can get the pattern using this we so-called secondary sequence. Okay, so given a sequence A1, A2, A3, A4, then using that sequence, the difference of 2 consecutive terms, you get a new sequence. Okay, so you get A2, right? The new sequence is A2 minus A1. It's not going to be constant, but you get B1. A3 minus A2, you get B2. A4 minus A3 can be 3. And then get AN minus AN minus 1 equal BN minus 1. All right, so now what? So in general, it's not going to be constant. So we get a new sequence. B1, B2, B3. So sometimes it's easy to figure out the pattern for the new sequence. Okay, then I can get a general formula. Okay, and so we can figure out the next term. So this new sequence, yeah, we can figure out pattern. Okay, so we can get a general formula. Okay, so let's take a look at the example here. Okay, given 1, 5, 13, 19, not 29, something like that. 29, 61. All right, what is the next term? All right, can you do that? So let's take the difference, okay? Just for that, we may be able to figure out general term, okay? So how can I figure out? Let's say, so this is A1, A2, A3, right? A4 and A5. So A2 minus A1 equals 5 minus 1 is 4. A3 minus A2, 13 minus 5. 13 minus 5 is 8. A4 minus A3 is going to be right, 29 minus 13, so 16. Okay. So A5 minus A4, 61 minus 29, right, is going to be 32. Okay. So from here, this sequence, oops. Yeah, this is called the secondary sequence we get, like a 4, 8, 16, 32. So it's just, this is a geometric sequence. So you just double it, right? So therefore, A6 minus A5 is going to be 32 minus times 2. Every time you multiply 2, 64. Okay, so therefore, the next term is going to be it's going to be 61, right? A5 and plus 64. So it's 125. 125, right? So Jaden's answer is correct. Right? Because I know A5. A5 is going to be 61, right? So you move to the right-hand side. Okay. Now the question is, can we find the nth term? I still have to go back. So A2 minus A1 equals 4, right? Right? A3 minus A2 equals 8. A4 minus A3 equals 16. A5 minus A4 equals 32. And keep it going. So I needed to figure out what is, right? 4 is going to be 2 squared. It's 2 cubed. 2 to the 4th power, 2 to the 5th power. So this is you see this file corresponds to that file. So an minus n minus 1. This should be equal to 2 to the, I think it's going to be 2 to the power n. Okay. Now on the right hand side, this is a sequence of numbers, but it's easy to figure out the pattern. As a new sequence of numbers, which clearly has pattern here. It's 2 to some power, right? So add them together. All the terms in the middle will be canceled out. So an's term minus a1 equals 2 squared plus 2 cubed, right? 2 to the 4th power all the way to 2 to the n. Okay, and what is a1? The first term. The first term is what? Is what? Okay, so we get the formula for this sequence, and you can double check whether it's correct sequence or not. Okay. Now, can I combine them into this infinite? This is the nth term here, right? Total there are n terms. Can I combine them into one fraction? I think it's possible. Here's a formula. Right. And we have formula 1 plus r squared all the way to the n is going to be, it is going to be 1 minus r to the n plus 1 over 1 minus r. Right? So we can prove this later. And many of you still probably know how to prove it. So can I use this formula to get about formula? And actually 2 to the 1 is missing in here, right? So an equals 1 plus 2 squared, right? So I'm going to add, because that's a missing term here. So add the 2 to the 1, subtract 2 to the 1. But once you add the 2 to the 1, and then this is going to be 1 minus 2 to the n plus 1, 1 minus 2 minus 2. Okay? And the denominator to be -1, so it's going to be, right? So the answer is, that is the formula. Not too bad. And then double check, right? Check. A1 equals 2 square minus 3 is 1. Okay, check. A2 is 2 cube minus 3, which is 8 minus 5. 8 minus 3 is 5. All right. And that's match the first few terms. A3 is 2 to the 4th power minus 3. So 16 minus 3 is 13. Yeah, great. So stop here. All right. All right. So now I'm going to ask you to find the next term and also the nth term. Okay, given 1, 5, 17, 53, 161. Find the next term and the nth term. All right, please give me the answer. If you get the answers, please let me know, okay? Yeah, I hope Christina can give me an answer. And then Michael. Okay, so we have Michael who gave me the next term, which is different from the other. Okay. And who is right? Michael's right. Okay. So we want to find the next term and the nth term, okay? So how can I do that? let's take a look at the difference, right? Okay, so this is a very natural idea, you know, to just use the difference. A2 minus A1, that's 5 minus 1, it's 4 squared. A3 minus A2 is 17 minus 5, and that is going to be 12. Okay, and A4 minus A3, 53 minus 17. 36, not too bad, right? A5 minus A4, 161 minus 53. Okay, 108. All right, so those are the numbers we have. So unless we have to figure out the pattern. What is next term of this one? This new sequence. Then I can, if I can figure out that, then I can figure out A6, right? It's the sixth term, okay? But what is the pattern, okay? 4, 12, 16, I think this is geometry series. The reason is from here you multiply by 3. From here you multiply by 3, from here you multiply by 3. So from here you multiply by 3, right? So A6 minus 161 is going to be 108 times 3. Right? Times 3. So, so A6 is going to be 161. Okay. So let's figure it out. It's a 5, 8, 8, 5, 8, 5. Now 1 plus 4 is 5. Okay. No, 4, 4, 8, 5. Yeah, 1 plus 3 is 5. Yes. 485. That's the correct answer. Now to figure out the general term, a little bit difficult, right? It should be okay now. We continue here, right? So this will be the first term times 3. This will be the first term times 3 times 3, so 3 squared. This will be first time 3 times 3, 3 cubed. This should be the first time 3 times 3 times 3 times another 3, so to the 3 to the 4th power. Okay. So the general term here, an minus 1, should be 4 times 3 to the, okay, 645, I know 654. So this should be n minus 2, not n minus 1, right? This is 4, right? 4 times 1. Okay. So if we add all of them together, all the terms in the middle will be canceled out. Only the last term and the first term. And here you get 4 plus 4 times 3 plus 4 times 3 squared, and so on, 4 times 3 to the n minus 2 term. How many terms here? This should be n minus 1 terms. Okay, you have n minus 1 equation there. Okay, now A1 is, I still remember A1 is 1, right? So AN equals A1 plus all those terms has a common factor, 4. Right? And A1 is going to be 1. Can we evaluate this? The answer is yes, because we already gave you the formula. The formula says that 1 minus r to the n minus 2 plus 1. So the n minus 1. Right? Remember the formula. Right? So when k equals n minus 2, then the k plus 1 is n minus 1. All right, so simplify a little bit. This should be positive, it's 2, right? 3 to the n minus 1 minus 1. So 4 divided by 2 is 2. Okay. And you multiply this out. and 1 minus 2 is negative minus 1. So double check. Yeah, this is my formula. And you double check whether this matches what we discovered. So let's take a look at the second term. Second term is 5, right? So 2 times when n equals 2, 3 to the 2 minus 1 minus 1. So it's just 6 minus 1, which is 5. Okay, so that's correct. So we get the nth term. Okay. So not only, we are in the advanced math course right now. It's not just trying to figure out the next term. We needed to, we need to get the nth term. Okay. Well, here's a question. Why this is going to be 1/9? Anyone can show that? All right, do you have any idea how to prove it? You let s to be 1 plus r to the n. Then I multiply both sides by r. So r times s is going to be here r times r is r squared, and r to the n plus r to the n plus 1. Okay. So now you take the difference, equation 1, equation 2. Right? So s minus rs, and this part and that part will be gone. So it's 1 minus r to the n plus 1. Right? So this will be 1 minus rs equals 1 minus. Finally, we solve for s. So you do get you can combine them into one fraction. All right, so let's take a look at the next problem. Given sequence 3, 10, 21, 36, 35. Okay, I want to find the next term, if possible, and the nth term. Okay, so this is not an asthmatic sequence, not a geometric sequence, but natural ways to do it take a difference. Okay, yeah, let's take a look at this, right? And right, so this is A1, A2, A3, A4, A5. We actually want to find A6. So at least you should be able to figure the next term, okay? Yeah. So the difference, A2 minus A1 equals 10 minus 3 is 7. A3 minus A2, it's 11. Okay. A4 minus A3, 36 minus 21, 15. A5 minus A4, 35 minus 55. It's not 35, 55. I'm sorry. 55 minus 33, which is 19. Okay. So this is my new sequence. It's can you figure out the pattern? Okay. So if you want to get the 6th term, okay, and we're supposed to be, the next, it's easy to figure out the next number in the sequence from 7, 11, 15, 19, right? What is that number? Yeah, at least you have to find out the 6 terms. Okay, if you get the 6 terms, and I think Jordan's answer is correct, then you can move on to get the next term as the nth term. Okay. Michael, do you have answers? Right. So I assume that you get to the nth term, right? And Kelvin, how do you get a smaller number, the next term? Right, it's increasing, right? 3, 10, 21, 36, 55. So the next term cannot be 23. Right? So Michael says actually it's yeah, the difference is 23, right? Okay. I'm talking about, yeah, this one is 23. I'm talking about A6, the next term in that original sequence, not the next term of this new sequence. Okay, so next term of this new sequence here, you add 4, add the 4, add the 4, right? Add 4, you get 23. Okay, then A6 is going to be A5 plus 23. And that is going to be 55 by 23, 78. Now the challenge problem is A6 is going to be 78. Come on. Good. Okay, right? Yeah, so next term of the new sequence, yes, is 23. Because this is the arithmetic sequence. Every time you increase by 4. Then the next term in the original sequence, which is the A6, is going to be 78. Don't confused. Okay, are we able to find the general term? Okay, so here we do. This is a 7 plus 4. And this will be 7 plus 4 plus another 4. So 4 times 3. This will be 7 plus 4 times 3. This will be 7 plus 4 times 4. Okay, and keep it going. An minus a minus 1. It's a 7 plus 4 times. What is that number? That number is going to be, I think it has 6, 5, and 4. So this will be next one, n minus 2. Okay. So you still have n minus 1 terms here. So add them together. All add them together, A2 cancel out, A3 cancel out. So what is left on the left-hand side is an minus a1. What is, so you get 7 times 4, 7 times, sorry, 7 plus 4, okay? 7 plus 4 times 2, and then 7 plus 4 times n minus 2, okay? So you have n minus 1 terms here. Say, how many terms here? N minus 1 term. So let's pick up all the 7s. So 7 times n minus 2. N minus 1, I have n minus 1 term. And then plus 4. And plus 4 times 2. Plus 4 times n minus 2. So this is a common factor is 4. Right? And here's 1 plus 2 plus 3 all the way to n minus 2. So mine is a general term. Okay, what is A1? A1 is A1 is 3, right? Yeah, A1 is 3. So AN equals A1. 3 plus 7 times n minus 1 plus 4. 1 plus 2 plus 3 all the way to n minus 2. Now, for this series, the sum of this sequence of numbers, we have a formula. Okay, I hope you remember. What is that formula? This is the total number, right? Multiplied by n minus 2 plus 1 n minus 1 divided by 2. Okay. Then you simplify. Let's simplify it. It's 3 plus 7 n minus 1, 2 n minus 2 n minus 1. Okay. And that's it. And you double check whether this is called the formula. You can look at you look at A1, 2, 3, A4. We know A4 is right? When n equals 4 is 3. When n equals 4 is 2, here times 3. Right? This is supposed to be 36. Let's see. And this is a 21. And 12, yeah? So that would be 36. That's correct. Right, that's it. So here we use a formula, 1 plus 2 plus 3 all the way to k is going to be k times k plus 1 divided by 2. All right. So our next problem, it's similar to this. I wish you can do that. Given 1, 3, 7, 13, 21, 31, 43. Find the 100th term. Actually, you just need to find n. I'm not asking you to find the next term. I want to find the nth 100th term or the nth term. Okay, please work on this. I hope you can figure it out. I'll give you a couple minutes, okay? You have to use in the above identity. That's my hint. Okay. So did I miss in terms? 1, 3, 7, yeah. 1, 3, 7, 13, 21, 31, 43, yes. Right, can you figure it out? The hundredths terms. So you have to basically have to find the general term, okay, the nth term. Then you let the n to be 100, right? Right. So how do you get it, right? So a2 minus a1 is 3 minus 1, that's 2, right? a3 minus a2, 7 minus 3, that's 4. a4 minus a3 is 13 minus 7. 13 minus 7 is 6, right? So now you can see the pattern. That's, since we get given so many terms, so we have to write down all the terms here. That is going to be 8, a6 minus a5, 31 minus 21, 10. Right? Pretty good. So they're all in the pattern. Okay. It's 12. So clearly this is all the even numbers, right? All the even numbers. So this will be more each time, just 2 times 1 here, 2 times 2, 2 times 3, you take the factor of 2 out. 2 times 4, 2 times 5, 2 times 6. So this is a sixth equation, right? So clearly, an minus 1 is going to be 2 to the n minus 1, okay? So, so the same trick, because if you take a difference here, right, on the right hand side, difference of 2 consecutive terms. So add them together, all the terms will be gone, just n and n1 left. And the right hand side is 2. You have 1 plus 2 plus 3 plus 4 and n minus 1. Okay. Do you really, do you remember this formula, right? So here's k is n minus 1, so it's k times k plus 1, that's n, divided by 2. So 2 cancel out. Then a1 is 1, I remember, right? a1 plus n minus 1 times n. So a is 1. Okay, so you get the general formula. Then the general formula, and then what is 100 terms? It's 1 plus 100 is 99 times 100. So 9,900 or 1. Okay, that is the answer. Okay. All right, let's try next problem. Given 5, 8, 20, 47, 95, 170. Okay, find the an, the nth term. All right. Well, similarly, right? So a2 minus a1 equals 8 minus 5 is 3. Okay. And 3 minus a1, 20 minus 8 12. Okay, A4 minus A3 is 47 minus 20. That's 27. Okay, A5 minus A4, 95 minus 47. What is that number? Okay. $95 minus 47 is 48. Okay, let's do one more. Okay, so 170 minus 97, 75. Okay, that's all we have. So we have to study the pattern of the second sequence, the sequence we got from the differences of the consecutive terms. Okay. Now, what is that? Okay, I look at all this, they're all divided by 3. Do you see that? They're all divided by 3. So why not divide by 3? So first of quotient 3, second is 4, and here 9, and 3 times, okay, 16, right? 3 times 25. Great. So I see the pattern already. Do you see that? Do you see that? You see, you get perfect squares, right? 3 times the perfect squares. That's it. Now, are you able to give me the nth term? I stop here for a minute. I hope you can figure out the remaining part. Right? So next term will be 36, right? 3 times 36. Right, so let's see. an minus 1. And here 3 should be equal to here 5 and 5, 25. For A4, 16. So this should be n minus 1 squared. Okay. Add the all terms together. The first term, last term left. All the terms in the middle gone. And then I have a 3 times 1, 3 times 4, plus 3 times 9, plus 3 times 16, plus 3 times 25. And keep going, 3 times n minus 1 squared. Those are the sum of perfect squares. So you take 3 out, you get 1, 2 squared, 3 squared, 4 squared, 5 squared, and n minus 1 squared. Now, are you able to combine them? If you cannot combine them, just leave like that, okay? But you get specific numbers, right? A1 is a 5. So that's why an equals 5 plus 3. 1 plus 2 squared plus 3 squared plus 4 squared. Okay, so you get this one. Okay, now I'm not satisfied with this answer because we really needed to know how to combine them. Okay, in some cases you can. Okay, so we do have a formula here. Here's 1 plus 2 squared plus 3 squared plus 4 squared all the way to k squared. Okay, is going to be k times k plus 1 and 2k plus 2k plus. 2k plus 1 divided by 6. So this is the formula, okay? And I'm not going to prove this here right now. So that's AN equals 5 plus 3, and that'll be 6. K is n minus 1. So this n is 2n minus 1 plus 1, okay? And that's it. You simplify a little bit, then you get the answer. Yes. Divide by 2, 5 plus 2n minus 2, 3n minus 1. Okay. So you will get a formula for the nth term. All right. We know how to add all the numbers, like 1 plus 2 plus 3 all the way to k. But when you add 1 plus 2 square plus 3 square, all the perfect squares, that is not trivial. Here, another formula here I want to mention is 1 plus 2 cubed, 3 cubed, 4 cubed, k cubed. And then this can combine, it's going to be k plus 1, and divided by 2 squared. Okay, so this is a formula we also use for sometimes. But right now we use this above formula, 1 plus 2 squared plus 3 squared. The sum of all the first perfect squares can be combined into one fraction. Okay, using that you can get the nth term. Okay, so once you get the nth term, you can get general. When n equals 2021, then just plug 2021 for n into this expression. Okay. I did not have a time to talk about other problems, but let me just mention this one. It's not always takes a difference. Okay, like this one, you have to see the patterns when you have to figure out how to get the next term. Okay, so so instead of taking the plus, you have to add them together. It's not always, yeah. Then you have to see the pattern. Then you see the pattern like 12 and the 7 plus 17, right? And the 24, and then this sequence has a pattern. Okay, 17 plus 31, 48. Okay, then you can solve the. So it's not always takes the difference, but the most of the problems we did here just takes difference of two consecutive terms, and you get a new sequence. Then you can figure the pattern, then add them together, you get the nth term. But like this one, you can only find the next term, but it's very difficult to find the general term, nth term. Okay, let me stop here. So you will see some example, additional example from my notes. Okay, bye-bye.